guys, welcome back to EC TechNest. In this lecture, we'll be discussing about the finite state machine of a seatbelt warning system. So there are three states in the seatbelt warning system. One is alarm on, next one is alarm off, and then waiting state. When the vehicle ignition is turned on and the seat belt is not worn within the 10 seconds of the ignition on, then the system generates an alarm signal for 5 seconds, and the alarm is turned off when the timer expires or if the seat belt is worn by the user or ignition is turned off. So whichever happens first, the alarm will turn off. So this is how you draw the FSM. Initially the alarm will be in off state, and when the ignition key is on, it checks whether the person has worn the seat belt or not. If the one person has worn the seat belt, then it will be in waiting state, and whenever the ignition key is off also, it will be in the waiting state. After waiting state, it goes to the waiting state. If the timer expires, it will move to the alarm on state if the seat belt is not worn, as well as the ignition key is on. Then after the timer turns off, it will go to alarm off state. So there are three states: alarm off, waiting, and alarm on. And events are ignition key on, ignition key off, timer expire, alarm time expire, and seat belt on. So this is how you write. The general FSM for a timer model would be ready state, running state, and idle state. It will move from ready state to running state on the start of the timer and also decrement the count value. And it will move from running state to idle state when the timer is stopped and sets the timeout flag. So here the event would be load the timer and action would be count the timer. So next one is sequential program model, in which you are going to write the program that will uh, it is a sequential program that will be written for the seatbelt warning system. So here you can see this is the block of code that you'll write: hash define on 1, hash define off 0, and hash define yes 1, hash define no 0. And if the ignition key is on and seat belt is off, then the alarm will be set for 5 seconds and alarm will start. If the seat belt is off as well as the ignition key is off, after the timer expires, it will stop the alarm. So this is in terms of the flowchart approach. Initially ignition key is on. It will wait for 10 seconds until the user is going to wear the seat belt. After that, the ignition key is on. If yes, it will check for whether seat belt is on, and if seat belt is on, it will directly move to the Y state, that is stop the alarm. If the seat belt is not on, then it will start the alarm. After the alarm is started, it will again check for whether ignition key is on, and then again checks for seat belt is on. The final state would be timer will be expired. Next one would be the embedded firmware development languages, that is the embedded language based development, in which we have assembly language programming, and it is the task of writing the processor specific machine code. So the syntax would be label, opcode, operand, as well as the comments. So label is an operational field and an identifier used for representing. Labels are suffixed by colon and begin with a valid character, can contain certain numbers from 0 to 9 and also the special characters such as underscore. And next we'll discuss about how to write the program ORG0100H, which is in hexadecimal, and you are going to load the resistor R0 with the value 255, and DJNZ represents decrement R1 and loop till R1. Next RET is the command used to return to the calling program. So there are various steps involved for the conversion of a program written in assembly language to the corresponding binary file or machine level language. So initially it has this source file. There are two source file here with .src or .asm file extension. Then it will move to the assembler or the module assembler. Both the source file will move to the module assembler. Finally it will move to the object file. And initially there is library files also present along with the object file. So linker or locator will map the object file as well as the library files together. Then it will move to the absolute object file. From the absolute object file it will get converted from object to hex file converter, and this is the final machine code that you obtained. So you have to explain in detail what happens after each step. Next one is conversion of assembly language to machine language, that is source file to object file translation. In source file to object file translation, translation of assembly code to machine code is performed by assembler. Assembler for different target machines are different. That is extrn is used to import a variable or function from a module, and public is used to export a variable or function from a module. Next is library file creation and usage. The main components used here would be linker and locator. It is another software utility that is responsible for linking various object modules. Linker generates an absolute object module by assembling, extracting the object modules. And an absolute object file or module does not contain any relocatable code or data. Next would be object to hex file converter. That is, hex file represents the assembly code in the machine code, assembly language code in the machine code, and is dumped onto the code memory of the processor or controller. So the hex file is created from the final absolute object file. Advantages of assembly language based development would be efficient code memory and data memory usage, along with high performance as well as low hardware access. So these are the advantages of using assembly language based development. Next one would be code reverse engineering. Code reverse engineering is performed by hackers to reveal the technology behind the proprietary products, and also most of the code will be protected but still can be easily converted into assembly code using the disassembler for target product code. Along with the advantages, there are certain drawbacks of assembly language based development, that is high development time. When we compare high level programming languages like C, assembly language is much harder to program. And next one is developer dependency. There is no common rule that is followed by developer to write the assembly code like in any high level language. And next one is non-portable. Assembly language instructions written for particular application cannot be used for another target processor or controller. So the next concept is high level language based development. First you'll have two source file in the .c or .c++ extension, and then it will be further transferred to the cross compiler block. From the cross compiler block it will move to the object file. Object file and library files are already present before, and linker or locator will connect the library files and object files. Next is absolute object file. Absolute object file will from the absolute object file it will move to the object to hex file converter, and finally we obtain the machine code. Next is cross compiler converts the source file to the object file. Advantages of high level language based development would be reduced development time, whereas assembly language takes more time, whereas high level language has reduced development time, and also developers independency. Along with portability, a code written in particular application can be converted to another target processor or controller with some modification. Along with that, we have limitations of high level programming also. Some cross compiler may not be efficient in generating target processor. And the last one is uh, embedded firmware design approach. There are different types of approach. The first one is super loop based approach. So this approach is based for adopted for applications that are not time critical, and the response time is not so important, which means that you will not get an immediate response from the system. There might be a delay in the response of the system. And the firmware execution flow will be configure the common parameters, perform initialization, and for various hardware components such as memory, register, etc. Next, start the first task and execute. Similarly, execute the second task and then move on with the further tasks, and execute the last defined task, then jump back to the first task and follow the same flow. So this is how you perform super loop based approach, in which there will be a step by step process, and after it reaches the last process, it will again jump back to the first process and also follow the same flow. So this is the super loop based approach. Thank you.